Hello everybody, this is Joe Thomas here, and today we'll be seeing about a new data structure called as Linklist. So Linklist is basically we create a node and we link that particular node to another node. So for creating a node must have a structure. So this is the structure of my node. So a struct node, and it have a integer type and a self-referencing pointer link that can point to another link. So in linked list we have a pointer called as pointer object called as head, which is initially pointing to null. So in this program we will see basically 6 functions. One is you want to insert a node at the beginning, and the next is inserting at the end, and add before a particular element, add after a particular element, and deleting a particular element or a particular node, and last one is to display the complete structure. So since it is node, each node, and this is a singly linked list, so there will be only one link, and that is what you see here. So each node will point to the next node, and it is unidirectional. So the second node will not know the address of the first node, but the first node can know the address of the second node. So here you could see that we are going to discuss about the first insert at the beginning. So we need to take an element A from the main method, and we need to create a temporary node using dynamically, and that's what you see here. And we check whether there is memory or not. If there is no memory, the operating system will return null value to temp when dynamically allocating. And then this statement shows that the value is added to the node, and temp arrow link is used to link the node's pointer to the head of the linked list. And initially head is null, so it will point to null, and head will be temp from there on. So this is inserting at the beginning, and when we go and check inserting at the end, we create 2 pointers of node type, and one is a temporary pointer that is for creating a new node, and another is a pointer named as monk that will be pointing to the head, and this monk pointer will jump from each node since we can't move the head. So this part is being cleared. So here we could see that temp is initialized with a data, and temp arrow link will be null because the last element will point to the null, and the monk pointer will jump from head to the last using this while statement. In the while condition we have monk arrow link not equal to null. So at the last node we can see that it will come and stop, and after that that particular last node link will be equal to the temp. So the last node pointer will point to temp, and further that is added to the linked list. And the next is add before. Here you need to accept 2 values. One is an integer for checking whether that is the element or not. So for that we use data, and the node value, the newly inserted node value, the integer part, is accepted from the main method in a variable named as a. So here also we need 2 temporary pointers. We create a node, and the monk pointer will be used to traverse from one node to another starting from the head. Temp will be initialized with some datas or some value a. In its integer part we have seen the structure initially, and head arrow info, if it is equal to null, that means if the first element, if it is equal to data, that means the search element. So if it is the first element, we need to reset the header as well. So for that, temp arrow link is equal to the present head, and head is shifted one step back, and that is to temp, and we return from there. If it is not, we are not inserting at the first element, we need to require the monk pointer that travels till we find the data. So for that we use the if condition. So since we have to insert it before, we need to stay one node before. For that we are checking monk arrow link arrow info. So we will be one node before, and we will be checking the next node's information part is equal to our search element data. If that is the case, the temp arrow link, the new node's link must point to the monk arrow link, and the monk arrow link should point to temp. So by that we are inserting at a particular position. So here you could see that I have some here. So if this is the element to be inserted, before this our monk would be here, and this is monk, and it is connected as like this. You could see it is connected. So what we are doing is, this is the temp node. So this is the temp node. So this must point to monk arrow link, and monk arrow link, that is this one, this node. Monk arrow link is pointed by temp, and monk's link should point to temp also. By this we are breaking this connection, and we are forming a new node in between both these nodes. So that is what happened there. And finally, if no element is found, that is displayed and returned. That is the another condition. So next we will come across add after. So in add after also, this is the same case, where you have an integer of a and another integer to search whether the particular node element is this, and we have created a temporary node. The monk pointer will be pointing to head as it is, and this condition is familiar. So after this we are inserting value to the temp new node, and then we are checking. So here we don't need to give monk arrow link arrow info, because we are on a particular node. Suppose we are suppose we are our our monk is here, and we have find that this is the search element to be searched, and we have reached here. So the monk so that the temp is the new node created, its link will be to monk arrow link, that is what monk is pointing to, and monk arrow link will now change to temp. So we have added after the searching node, and that is also done. And now we have left our deletion. So here we are searching a particular node and deleting it. So initially we have to check a condition where if our linked list is empty or not. For that we check whether head is null. If not, we proceed, and we check whether the head arrow info, that is we are trying to delete the first element. So if we are trying to delete the first element, we need to reset the head pointer as well. For that only we are giving this if condition. Here temp is a temporary pointer that points to the present head, and head will shift to the next node, and we are deleting the node to which temp is pointing. This deallocates the memory, and we return. If that is also not the case, there is one more area where we need to check whether if the element is in between or end or somewhere. So for that we traverse through the linked list using a monk pointer. Okay, monk arrow link not equal to null, and we check whether monk arrow link arrow info similar to add before. We check whether it is equal to particular element. If that is equal, the next node in which the monk is sitting, the next node in which the monk is sitting should sit is pointed by temp, and monk arrow link would next be pointing to temp arrow link. That is, here if suppose we have, okay, if this node is to be deleted, okay, so our monk will be here and it finds that this is the node to be deleted. So monk, okay, so temp will point here and temp arrow link is this node. Okay, so in this example let's take that the linked list goes like this. So uh, this is the next node. So monk arrow link will be pointing to temp arrow link, and this will be cut. Alright, so this node is removed from the list and we are deallocating that through delete temp, and we return. If not, we are returning no element found. And this is a very important syntax to shift the monk pointer from to each node. And this is the main part where you can see a user defined menu driven program for each. Now let's run this. Okay, insertion at the beginning. I want to insert 1, would like to continue. Insertion at the end, I would like to insert 2, I would like to continue. Now let's display and check. Yeah, 1 and 2 is here, 1, after that 2, and now I would like to display after an element. So since I have 1 and 2, I can display it after 1. So element to be inserted is 4, element to be searched is 1, continue. Now let's display it 1 4 2. Now if I want to add before, let me see, I can do that before 2 suppose. Okay, so my element to be inserted is 6 and I want to search till 2, and now let's display the function. Yeah, 6 is inserted before 2 and you could see that. And now if you want to delete something, 5, and I want to display an element named 6. And now if I would like to see, I give display and 6 is eliminated. Now if I want to delete the first element, that was also a condition, let's see that as well. 5, and we delete 1, would like to continue, yes, and display the thing. Yes, 1 is removed and we have 4 and 2. And that's it. This is the end of the program. Thank you. Hope you understood.